Today's topic is optimization and how to optimize molding parameters with DOE. So if you have no idea what this DOE and optimization technology is, that's completely okay, because what we're going to do is we're going to go over a quick overview of what this is about. Um, just the copyright and disclaimer information. But here's an outline of this presentation. First of all, we're going to cover the trial and error method that we typically use in our operation. What you're using right now when you see the problems on the production floor, what we do is we try to make changes on the floor and try to see if we can find a solution to it, right? And then we're going to talk about, switch some gears and go towards the simulation aspect, how you can use those or how you can try those trial and error virtually inside the simulation, right? Inside MoldX 3D. And the next one is taking it to the next level, like how we can optimize and use this DOE feature in our simulation to make sure all we are optimizing our part design, our tooling, and processing. I also have a lot of case studies, so that is going to be my major focus because always we being engineers, we are always interested in knowing the real application on how folks around the industry are using this technology. So we have about 3 case studies, different applications, automotive, consumer products, which we're going to cover. That will give you a good understanding of the actual application and how people are using this in their actual operations. So with that said, injection molding process. So it is a very complicated process, right? There is a lot that goes inside the mold, and everything is happening simultaneously. For example, as soon as the material enters the mold, right, it starts to fill in. Its viscosity is changing, right? It's trying to shrink and warp, right? Its temperature is changing. During the packing phase, what's happening is the part is trying to shrink and warp on the mold surface, right? And the mold is acting as a constraint. It doesn't allow the part to shrink and warp. So what ends up happening is it will start building up stresses, right? If it's a semi-crystalline material, it will start to crystallize, right? So all those things happen simultaneously. What we want to do is we want to understand, what goes inside the mold. And how do we do that? Through simulation. Right, we can run this simulation beforehand to understand exactly what's happening with your fibers, what's happening with your crystallization, how the part is shrinking, warping. Do we see any stresses that are building up to help us design better parts and also design better tools?